Okay, grade 11 pre-cal. This is lesson 19, factoring quadratics in standard form. So this goes back to the stuff you learned in previous grade. We're going to take these trinomials or whatever we happen to get, and we're going to factor them into usually binomials. So look at this first one here. First thing you always got to look for is you always got to look for a GCF, right? The greatest common factor. So if you notice, we can take a 2 out of this whole thing, right? 2x squared divided by 2. 2x divided by 2, 12 divided by 2. You can see here we get our x squared minus 6, x squared minus x minus 6. Then you got to take that trinomial and factor it into two binomials. You can either do it by decomposition method, which you might have learned, or you can just straight factoring. So you're looking at factors of 6 that when subtracted give you your 1 here, right? So then we have our x plus 2 and our x minus 3. Okay. This next one, 5a squared minus 16a plus 3. There's no GCF, so you just try to factor it. What are the only factors of 5a squared? 5a and a. Only factors of 3 are 3 and 1. This sign here, this positive, tells you that both signs are the same. And in this case, they're both going to be negative. So we just put our negatives in here, and then we check, right? So 5 times 3 is 15. 1 times 1 is 1. Added together, yeah, that's where we get our negative 16 from. Now this one, first thing you got to do is you got to realize, oh, it's in the wrong order, right? We always put them in descending order. So that would be 6y squared, and then put the plus 23y, and then the plus 20. And again, factors of 6 could be 1 and 6, 6 and 1, 2 and 3, 3 and 2. You can do it by decomposition, but as you get better with them, you'll just realize what the factors are. And the 20 is either 1 and 20, 2 and 10, or 5 or 4, whatever it happens to be. So let's double check this one. Now, this positive here means the signs are the same, and in this case, they're both positives. 2 times 4 is 8. 5 times 3 is 15. Added together gives us our 23, right? So for instance, let's say you had the 4 and the 5 backwards. When you do that, the part of FOIL, like the O and the I, the outside and the inside, you realize, oh, I got the numbers wrong, and you just rearrange them. Okay, what about this one? This is a weird one. You get a fraction in front of the x squared. Well, one of the easiest ways is if you times everything by 4. Get rid of the fraction if that helps. So if you put a 4 out here and multiply by 4, right? 4 times a quarter is just x squared, right? Negative x times 4 is 4x. 4 times negative 3 is negative 12. Now, I find this here way easier to solve. So it's negative here in front of the 12. That means our signs are different. We look at factors of 12, right? It could be 1 and 12, 2 and 6, 3 and 4. So you just try it. So in this case, 2 and 6, because x times negative 6 is negative 6x. Positive 2 times x is positive 2x, but added together gives us our negative 4. Great, that's what we're looking for. Again, this is just a review of the stuff we did in the previous year. Okay, next page. Now, sometimes you're going to get weird-looking polynomials that have patterns to them. It's like, look at this one. Oh, okay, so instead of just a variable here, we got an m plus 2, and instead of variable here, we have an m plus 2. Well, if you're struggling with that, take out the m plus 2 and just replace it with something you know how to use. So in this case, let's replace it with an x. Okay, so if I see an m plus 2, I'm going to replace it with an x. So then we have x squared minus 2x minus 3. Super easy to factor in that case, right? Negative in front of the 3 means the signs are different, right? Only factors of 3 and 3 are 1. So x times positive 1 is positive 1x, and this negative 3 times x is negative 3x. Added together gives us our negative 2. Perfect. Then now that we've factored it, can you substitute back in m plus 2? Yeah, so there was an x there, replaces it with an m plus 2, and m plus 2, and then you just simplify, right? So m minus 1, m plus 3, right? You just deal with the constants here. Okay, so that's a basic understanding, more like a review of factoring quadratics.